Okay, let's graph some inequalities. Well, let's say we're given y is equal to 2x plus 2. I'm going to show you a little trick. It would be better to understand the entire concept, but ain't nobody got time for that, right? I'm just kidding. Okay, so when we graph slope-intercept form, we start at 2, we go 2 up, 1, 2, and we go 1 right. I would recommend you watch a video on how to graph these functions if you are unfamiliar with them. I do have a video somewhere. So here's our function, y is equal to 2x plus 2. Now what if they say y is greater than 2x plus 2? What do we do now? Well, we do the exact same thing. But very important, when you see an inequality, you used a dashed line. When you see an inequality with an equal sign, you use a closed line. Because this means that this could be a possible solution, but any of these are not a solution on the exact number. I'll show you what I mean now. So let's do it again. Start at 2, go 2 up, 1, 2, 1 right. Now we just use a dashed line. Now an easy way to shade is to look at your inequality symbol. If your inequality symbol shows that y is greater, we shade upwards. Okay, we shade up. You shade this entire region. So what happens when we say, well, y is less than 2x plus 2? Well, in this case, I'm going to have the exact same function. 2 up, 1 right. Now we just shade downwards. We shade down. And you might be asked in some exam to test if this is in fact correct. So what do they mean by test? They mean take a point, any random point in the shaded region, and test it. So let's test one. Let's use 1 and let's say 7. We're going to use 1 and 7. Okay, so the coordinates I'm going to test is 1 and 7. This is within my shaded region. I know that y, I'm going to then substitute my x and my y. So 7 is greater than 2 multiply 1 plus 2. So 7 is in fact greater than 4. This is how we know our shaded region is correct. If I had to use any one of these points, the statement will not be true on the exact line because it's not included into my equation. Okay, so that's how we shade up and down. Now what happens when they give us y is equal? Let's see if we can make some conclusions what's happening, because if you can conclude what's happening, you get the idea. So we have this parabola. This is the function y is equal to x squared. Now what if they give us that, well, y is less than, or is greater than x squared? Well, we're going to sketch a parabola. Remember, very important, a note. A common mistake I see in exams is that students forget to use the correct drawing. Okay, with an inequality, we use correct drawing. So your parabola is going to look something like this. Symmetrical on both sides. So let's test the point. Let's go for 1 and 5. 1 and 5 is definitely within this region. Okay, it's within the region. But let's see if we can conclude what's happening. So I'm going to use the points 1 and 5. So y is equal to 5, and 5 should be greater than the square root or 1 squared. That is in fact true. So now we know when y is greater than my x values with a quadratic function, we're going to shade within the parabola. And if it's less than, so if we have y is less than x squared, of course we're going to just simply shade downwards. It's as simple as that. Now let's say you completely lost, you completely forgot every single thing you've learned. Okay, what do we do then? Well, is there a solution? Yes, there is. Let's say they're given y is greater than or less than 4x. Let's say they give you that function. now we can see it's greater than and equal. So we're going to have a straight line. So 4x is going to look something like this. 4x, it crosses through the origin because we have no y-intercept, no intercept, which means there's no vertical shift, okay, up or down. So what I can do then is I can simply test the coordinate. Well, let's go test this one. Let's go test some random coordinate. Let's call this part, we're going to call that region 1, because you only have two options, right? You only have up or down. Let's call this region 2. Let's say I'm lost and I forgot that, oh, I'm supposed to shade upwards when y is greater than the function. What can I do? I'm going to go test a point. Let's go test 0, 5. Let's test 0, 5. Okay, so y is equal to 5. And, excuse me. What am I doing? 5, 0. We have a x coordinate and we have a y coordinate. So let's go test. Let's say, well, 0, in this case, our y is equal to 0, is greater than or equal to 4 times 5. 0 is in fact not equal to 20. So this statement is definitely not true. If the statement is not true, I can then conclude, wow, whoa, I am not shading this region. So I'm going to shade the top region. Okay, that's an easy way to test in an exam. Slope of 4 means it's a strong incline. So we're going to shade the up region. Okay, that's pretty much what we can do. Now you can do this with any type of function, whether it's linear, quadratics, cubics, quatrics. You can always do this. You can test a point and then you can shade that region. Okay, easy stuff.